Okay, so if you want to follow along in your textbooks, it's page 146. And we're going to talk today about translations and later today about reflections. Before we do, some key vocabulary words. The first one is this idea of family of functions. And what that is it's a group of functions with similar characteristics. When they have similar characteristics, we call them a family of functions. The most basic of all family of functions is called the parent function. It's this is an example of a non-constant. See, there's no b in there, so it's a variable parent function. It's simply f of x equals x. And we'll take this parent function and we'll change it in subtle ways in just a little bit. You'll see what I'm talking about. If I were to graph f of x equals x, though, we can remember from our previous lessons that f of x is just function notation for y equals x. So for each value of y, if y were 1, x would be a 1. If y were 2, x would be a 2. So if we were to graph that real quick, it would look something like this. So this parent function is just a positive slope going diagonal across the street, across the graph, and we would change this in some way. So let's start with translations. A translation is a transformation that shifts a graph horizontally, meaning left to right, or vertically up and down, but does not change the size, shape, or orientation of the graph. Horizontal translations. The graph of y equals f of x minus h is a horizontal translation. So again, going back to that parent conversation we just had, it's very similar to f of x equals x, but there's just one change, and that's there's a minus h inside the parentheses. So we'll give you an example of that in just a second, but notice too that when it's in this format of in the parentheses, the graph is going to change. It's going to translate even to the left or to the right. And then it tells you a little hint here, but I think my explanation will be better, so we'll go over that in a second. Vertical translations are up and down, are of this format. F of x equals the x again, but it's going to be plus a number. They're saying k. Whatever that number is, we'll move it up or down. So we'll do that in just a second. We'll go ahead and get started with it. So let's start with this first one. It says, let's graph f of x equals 2x minus 1. And then it tells you to graph g of x equals f of x plus 3. And then one other, t of x equals f of x plus 3, and the quantity. And then describe the information. So looking at this first one, this is like this is the family that they're all based of. We'll start with this one, and then we'll take the graph of f of x, and we'll insert it into this g of x. This is the same thing. This is the 2x minus 1. And then we'll transform it by 3. And then later on, we'll take the same graph and we'll transform it horizontally by 3. So let's look at the first. I just rewrote the function notations here. So I went ahead and found the m, -1. The b is, the m was 2 over 1. And I graphed it for us here. So we have the straight line, but now we're going to translate it here. I'll use the blue marker to indicate it. So it's still the f of x. It's still going to be this one, but we're going to shift it. We're going to translate it plus 3. That means everywhere that this graph is, we would move it 3 up. So every point on the graph, just go 3 higher. 1, 2, 3. 1, 2, 3. Wait. 1, 2. And that's your answer. Okay, let me do one more down here. And so we see that when it's being added to at the end, it's not inside the parentheses, it's a vertical translation up because it's positive 3 units. So you take this line, you move it up 3 units. Another way you could have done this is taken any one point, going up 3 units, and just keep the same slope. Up 2 over 1. Up 2 over 1. It would still be on the same line. Down 2, down 1. Now let's take, that was a vertical move because it was on the outside. But what happens if it's inside the parentheses? Well, then it represents a horizontal move. So we're still going to look at this same family function, and we're now going to translate it horizontally. Now, if it says plus 3, the temptation is going to be to go to the right. But actually, and we'll show you why in another lesson, when it's plus 3, we go to the left. So we take this, any point, and we move it to the left. 1, 2, 3. There you go. 1, 2, 3. 1, 2, 3. And if you don't want to count, you can just get any point, and again, keep the same slope. Rise 2 over 1. Rise 2 over 1. 2 over 1. And then just, there it is. So this would be a horizontal transformation of the line. One more sample problem. So let me go ahead and do this with you real quick. You're going to find the m and the b. The m is 2 over 1. The b is 1. So we'll start at 1. Then we'll rise 2 over 1. 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 Go down 2 over 1. And we'll draw a line. Okay, so how are we going to translate it? Well, it says f of x minus 3. So we're transforming it a negative 3. Remember, if it's outside the parentheses, it's a vertical translation. So we're going to go down 3. And we could do that with every dot. 1, 2, 3, every point, every coordinate. Or once you get a coordinate, you can also just take the slope, which is 2 over 1, and count. Either way works. And we have successfully transformed this line with the translation. One more example, and then we will be done with this idea. So again, I took the same parent equation, 2x plus 1. I'll start at positive 1. I'll go up 2 over 1, up 2 over 1, 2 over 1. Okay, down 2 over 1. I'll draw my original graph. And then how is it shifting? How is it transforming? What's the translation? Well, it's inside the parentheses, so that's a horizontal transformation. And since it's negative 3, we're going to the right. So any point, 1, 2, 3. I'm just going to use the slope now. Up 2 over 1, up 2 over 1, down 2. Down 2 over 1. That's pretty good. I probably can write it from there. And there you have it. You have a transformation. We translated the original line over 3 to the right.